That's the result of a collision between neutrino and matter in the ice, typically the ice itself, nucleus. So over here, I'm Jim Haugen. I'm the instrumentation manager for IceCube. This is Dennis Dooling, our drilling manager. Tom Hutchings, our on-ice lead. And Mark Krasberg, our senior scientist on station right now. So what we're going to do is we're going to walk around here at drill camp. And the drilling is using hot water. So we're on ice. If we go all the way down to bedrock, it's 2.8 kilometers. So for us to drill these holes like this, 2.5 kilometers deep, we do it in a fairly straightforward manner. We use pressurized hot water and melt the ice. And then form a big loop, recirculating loop, repressurize, reheat, and then just keep drilling and drilling until we're done. It takes us approximately 24 hours to go down. Yep, 24 hours down, 6 hours up. So this is the camp. It stays here all season long. It's where we make the water. And on the back side where you guys took that little roundabout where we'll be going back is the tower where the actual drilling is occurring. This entire field, if you see all these flags, you see flags in front. When you were out at the South Pole Telescope, you saw flags behind, flags all over here. Those are all IceCube holes that have been... so with that, Dennis is going to take you around the camp, and then we're going to go up to the tower. We'll get a chance to look down one of these holes, and we'll go from there. So Dennis, you're up.
The University of Wisconsin, and that's who runs this drill. So,
yep.
Thank you very much.
Yeah, we're going this way.
All right, be careful right here.
What's the ice here?
I'm meaner.
I didn't tell him.
We'll just let it happen, man. It'll be fine. Go ahead. So when I talked about these holes, you can actually see as we have a deep array, and we also put an array of these detector modules at the surface, which we call ice top. So you see these little white things popping out of the surface. Very near each one of those is an IceCube hole. So we actually have a surface array. And the hole we're drilling is over there, and you can see the tower. You can see what looks to be like the world's largest garden hose reel. That contains that 2.5 kilometers of hose that we're moving the water through along with the drill cable. So what you see here is the return water line, and the supply water goes out there. So what Dennis is going to be showing you back over here is we have a high pressure pump building, and we have 4 heater buildings, and in each one of these heater buildings are 9 heaters. So we pressurize, heat the water, it goes out the supply line, brings around the hose, up over the tower, down through the drill head, and then that's what we're doing. We put a pump at the top of the hole so that we collect the water and we return it and do it again. So we just have a big giant loop established. We can only drill, we all get here in early November, we leave in early February. It's a very limited season.
Basically, it equates to like a Burlington locomotive amount of power going out a 3/4 inch hole. And that's the reason we can drill such a hole in such a time frame.
Power of the locomotive
out of yes, and it's hot water. It's 1,000 pounds pressure, 200 gallons a minute at about 90 C, and that equates out to about 6,300 volts.
And that thing just drills right through the ice.
Jets right through it, melts it, and jets it out of the way. About 2 meters a minute going down, which is pretty fast. And like I said, it's the only thing of its kind around. And one more time.
Mark Krasberg, at University of Wisconsin. So, as Jim said, so this is like a $270 million telescope, okay? And it's a neutrino telescope, and it's called IceCube because it's a kilometer high we're instrumenting a kilometer high of ice from 1.5 kilometers to 2.5 kilometers, and it's over a square kilometer of ice. So it's a cubic, we're instrumenting a cubic kilometer of ice. Okay, now, let's see, why neutrino telescope? So every time humans have built different types of telescopes, starting with, say, visible light telescopes, and then, say, higher energy telescopes, microwave telescopes, gamma ray telescopes, every time they've done that, they've uncovered a new understanding of the universe. Okay? And they've also discovered things they never, ever dreamed were out there. Every time that they built a new type of telescope. And you can imagine, like, you take a picture of a person, and then you take a picture of the person, say, with infrared, or you take a picture of the person with microwaves, and you learn a whole lot about the person that you didn't know before. Okay, we're taking a picture of the universe, or we're taking a picture of the universe with neutrinos. We basically make a map of the universe
it like this, or we got the strap on, because whatever goes down here, it ain't ever coming back. But if you come over and you want to, take a look, I got the light here. But you can hold your hand on this hose. This is the actual drilling. So going through here, this is 88 degrees C. Put your bare hand on it to feel the warmth. 200 gallons a minute. At this point, it's probably maybe 800-900 pounds per square inch. So all that water is coming out a nozzle that's basically the size of your thumb. And then this hose here is attached to the return water pump, which is you can actually see the water down there, and then that's establishing the entire loop. So if you take a look, so you can grab it, but just be very ginger. Come carefully.
I'm going to come on your all sled.
Respect the hole. Well, and that's. Hey, who's in the control room there, Mark?
Misty.
Hey, Misty.
It's one of the holes.
Misty, how deep are we now?
We're about 1440.
So this is the top 50 meters. There's another 1,400 meters underneath that, and then we have another kilometer to do.
Yeah, I'm going to shoot some video. Can I get one last video shot here?
Oh yeah, sure. Let me cut this.
Yeah, cool.
Yeah, no, it's true. As a journalist, I don't expect my writing to last more than about 24 hours.
I think about that too.
Yeah. The time scales of tens of thousands a year are a little bit hard to actually imagine in the great scheme of things.